The previous problem had an ordered list to work with. So the previous problem was the binary search algorithm. Notice we had a list that was increasing. In other words, it was already ordered. Suppose that we have an unordered list of unique elements. Sorting is the process by which these elements can be placed in an increasing order in a list. So sorting is a process to order your list. There is a large number of sorting algorithms, and many more continue to be devised. Bubble sort. Bubble sort is one of the simplest sorting algorithms, but it is not an efficient one. It puts a list into increasing order by successively comparing adjacent elements, interchanging them if they are in the wrong order. In the bubble sort, the smaller elements bubble to the top as they are interchanged with larger elements. The larger elements sink to the bottom. In each full pass, interchanging a larger element with a smaller one following is conducted starting at the beginning of the list until the end. Okay, so this is the first pass. So you have 5 elements. These are the elements. You want to write it in a sorted fashion. What does that mean? You want smaller elements to bubble to the top. So what are we doing? First we are comparing these two elements. So the smaller one has to bubble up. That is, these two get exchanged and you're here. So 3 has come here. 3 and 4. Notice 4 is bigger than 3. So it stays there. There is no bubbling. Next, 4 is being compared with 1. 1 is lighter, so it goes up. 4 comes down. Lastly, 4 and 5 are compared. They are in order, so heaviest ones in the bottom. That's the first pass. Notice you started comparing the top two until the bottom two. Now second pass. What happens is, in the first pass, the heaviest element comes to the bottom. So the bottom one is boxed away. Now you're in the second pass only going through the top 4. That is, instead of the entire list of 5, the bottommost is boxed off, so only 4 are left. Compare 2 and 3. Well, 2 is smaller, it stays in the top. Compare 3 and 1. 1 goes up, 3 comes down. Compare 3 and 4. It is in order. Now 4 is in the lowest one, it gets boxed up. You are comparing these 3. Compare 2 and 1. 1 comes up. Compare 2 and 3 is good. It is actually ordered, but our computer doesn't know. So it goes for one more pass, compares 1 and 2. There is nothing to do. So notice for a list of 5 elements, 5 distinct elements, you needed 4 passes. So now here are the steps. So the 5 is a particular number. In general, what do? You take an unordered list, go through the procedure itself, right? So here is a pseudo code. The procedure name is bubble sort, takes A1 through AN, they are real numbers, and you need at least 2. That's what it means, n greater equals 2. You need at least 2 elements to sort. If you have only 1 element, nothing needs to be done. For I going from 1 through n minus 1, right? So you see we had 4 passes for a list of 5 elements. So you have a list of n elements, so you need n minus 1 passes. What do? You see, in the first pass, the heaviest element comes down and stays there. So the heaviest element gets boxed up. So you don't sort for the heaviest. So first pass, you have 1, 2, 3, 4 um, checks in first pass. In second pass, you have 1, 2, 3 checks. So you see n minus I. So I goes from 1 through n minus 1, those many passes. And the number of pass has to be subtracted from n because you see the lowest ones are heaviest. They get boxed in, right? After first pass, 1 is boxed in. After second pass, 2 are boxed in, and so on. Now you are comparing AJ with the AJ plus 1. That is the very next element. If AJ is bigger than AJ plus 1, that is, if a bigger number is above, you see, so AJ is greater than AJ plus 1, then interchange. That's all. And at the end of it, you get an output which is a list of in increasing order. This is your bubble sort. The next one is insertion sort. We'll come to this in our next video.